Good afternoon, dear students. So today we are going to see the how to do the vector formulation for moment of a force. We know that moment of force is nothing but the product of the force into its perpendicular distance. Now the moment of the force about a point can be expressed as a cross product. Now you can see from the figure the force acting at point A, F is the force acting at point A, and R is the perpendicular distance of the force from point O where we are going to take the momentum. So how to find the how to represent the moment and as a vector form. So moment of force about a point can be expressed using cross product MO equal to R cross F. Now R vector cross F vector. Now R cross F can be expressed as to find the magnitude of the cross product. We know that R cross F is nothing but RF sine theta. So R into F is the magnitude of the force into theta is the angle sine theta. So treat R as a sliding vector. Since D is equal to R sine theta, so this can be written as MO equal to R of sine theta or F into R sine theta, or I can write F into D. Now, since we are representing this R sine theta in the form of T, so now we get MO equal to F into D. So this helps us to determine the magnitude of the force. So to find the direction, so direction and sense are determined by the right hand rule. Now, how to apply the right hand rule? Curl of the fingers indicates the sense of rotation. The curl of this finger indicates the sense of rotation. So maintain proper order of R and F since cross product is not commutative. So RF you have to correctly write because it's not F cross R and R cross F are both different. So you have to write correctly the R cross F. Now using the principle of transmissibility, the force applied at any point can be transferred to the point along its line of action. So for a force F applied at any point A, the moment created about O is nothing but R, that's a position vector RA into F vector, and the force has the properties of a sliding vector. So thus we can write MO equal to R1 cross F, that is equal to R2 cross F, that is equal to R3 cross F. Since this force can be transferred to any point along its line of action. So you can write the force at acting at this point can be written as M R1 cross F, or if we move the force along its line of action, can be written as R2 cross F, or if we move the force to third position, it can be written as R3 cross F. Since as per the principle of transmissibility, a force can be transferred along any point of along its line of action. So R1, R2, R3, depending upon the point on which the force is acting, the position vector R1, R2, R3 can be changed, but the moment about that particular point is going to remain the same. So we can easily apply the principle of transmissibility and find the moment of the force. We can do the vector formulation for the moment and get the result. So as of now, we have seen about what is a moment of a force, that is force into the perpendicular distance, and the moment has sense, that is it can be a clockwise moment or it can be an anti-clockwise moment. Clockwise moment is considered as negative and anti-clockwise moment is considered as positive. So the rotational tendency of the body is determined by the moment, and based on determining the rotational tendency of the body, we can provide the supports to arrest the rotational tendency.